Okay, let us begin with a new section that is a 3.4 Hermite interpolation on your notes, page 64. So in this section, we're gonna study about a Hermite interpolation that involve the function value of itself and its derivative as well. So now, what is the strategy of the Hermite interpolation is to develop an interpolating polynomial which equals to function and its derivative up to p order. So that means the derivative of the function is the higher order of the derivative of that function is only until p order, okay? Where you have n plus 1 data points. Right? Then what is the degree of this polynomial function then? So the degree of this polynomial function must be p plus 1 times n plus 1 minus 1 degree. Alright, so please remember this. Now, what is the lowest degree of Hermite interpolating polynomial? It must be in cubic, so the lowest. So we do not have a Hermite interpolating polynomial with degree 1 and degree 2. Remember, the lowest degree of Hermite interpolating polynomial is cubic. Okay, it is cubic. We do not have a Hermite interpolating polynomial with degree 1 and 2. Okay, so let us take a look for how we're gonna find the Hermite interpolation. Okay, so let us take a look for example 16 on page 65 of your notes. So this is about cubic Hermite interpolation. So the question sounds that develop a 2 data points Hermite interpolation function which passes through the function and its derivative first. Okay, you see, first derivative for the interval 0, 1. So that means the x value is in between 0, 1. So can you see that you are given that xi where your x0 is 0 and your x1 is equal to 1. And your fx0 is given f0 and your fx1 is given as f1. And this is your f prime, you see, first derivative. So f prime x0, the value is f01. And then f prime x1, so the f value, the value of f prime is f1, 1. Okay, so now we know that. Okay, so I'm gonna to write down the solution here. Okay, so in this case, what do you know? So in this case, we have, what is a p? Because you need to know what is the p order, all right? The derivative up to p order. So what is the derivative up to which order? So in this case, we have only f prime, am I right? So that means this one shows that your p is equal to 1, okay? So this is the order. So we have p equal to 1, and how many data points that we have? And the number of data points is equal to 1 data point, 2 data points. So we have 2 data points. Okay, so from here we know that this is represent the number of data points. Okay, and what is your p equal to 1 represent? So this is the highest degree of derivative. Okay, so if you have f prime prime, then your p is equal to 2. If you have 4th order of derivative, then your p is equal to 4. The number of data, how many data you have? If you have 10, 10. All right, so here we have only 2 data points. Now, if you know that n plus 1 is equal to 2, then you also know that your n is equal to 2 minus 1. So you know that your n is equal to 1. Okay, so you know that your n is equal to 1. Okay, so next, you want to know, okay, next is you want to know what is the degree of the polynomial function. All right, so then we want to know what is the value of p plus 1 times n plus 1 minus 1. That would be the degree. But And another thing that we want to know is how many constraint equation that we need. Degree, the formula will be p plus 1 times n plus 1 minus 1. But if you want to know how many constraint equation, then we only do p plus 1 times n plus 1. Okay, so now what we need, okay, we must impose p plus 1 times n plus 1, which is equal to, your p is 1, so you have 1 plus 1. Your n plus 1 is equal to 2, okay? Times 2, which is equal to 2 times 2, which is equal to 4. So you need to have 4 constraint, okay? You need to have 4 constraint equation, okay, to develop the degree. So that means it's p plus 1 times n plus 1 minus 1, okay, which is equal to, you have 1 plus 1 times 2 minus 1, so that means you have 4 minus 1, this is equal to 3, okay? So 3, you know that, okay, I put a bracket, this is the calculation, okay? So to develop a third degree of polynomial. Okay, so we know that we have a third degree. How to find the third degree is from this formula. Okay, this is a formula that you need to know. How many constraint equation that we have? It is 4 constraint equation that we have. All right, so now what we have to use. So you know that you need a third degree of polynomial. So third degree of polynomial, usually we can have like the form of a0 plus a1x plus a2x squared plus a3x cubed. So this is the third degree of polynomial. If fourth degree, okay, so you see, now if we have fourth degree of polynomial, then we have to use a0 plus a1x plus a2x squared plus a3x cubed plus a4x power of 4. Okay, so this is the fourth degree of polynomial. But now we only need to use the third degree of polynomial, so we proceed with that. Okay, so then what information that we have to use? So then we need to use 2 information. So one is we need a fx, which is equal to a0, third degree of fx. Okay, so we have a0 plus a1x plus a2x squared plus a3x cubed. Okay, and you need another information. How we know? You see, we have fxi, and then we also have f prime xi. So that means we need to find f prime. Okay, so now we have our f prime x, which is equal to, you differentiate a constant, a0 is a constant, you get 0, differentiate a1x, you get a1, differentiate a2x squared, you have 2a2x, when you differentiate a3x cubed, you have 3a3x squared. Okay, so we need to use these 2 information. Okay, after that, what you should do, so then we can begin to applying the constraints. So based on the information that we have, we can create the constraint equation. All right, so first we want to see what is our first xi. So the first xi will be x0. Okay, the first xi is 0, and then the second one we have to make full use of f1, okay, where your x1 equal to 1, and then after that we want to find f prime x0 and then f prime x1 is equal to this value. Okay, so fx0, which is equal to f0, is equal to, you substitute x equal to 0, so a0 you copy, and then x0, so 0, x is 0 squared give you 0, 0 cubed still give you 0. So that means we have f0 is equal to a0. Okay, next, what is our fx1? That is equal to f1. Okay, so this is your x1, so it's 1. So what is the value? So you substitute x equal to 1, so a0 you copy, and then here is a1 times 1 give you a1, and a2 1 square give you a2, and a3x cubed give you a3. Alright, next we have f prime x0. Okay, this is equal to f prime 0. So you substitute x equal to 0 into f prime, so you have a1 here, so you have a1, and then this is 0, this is 0, so that means you only have a1. Okay, and then for f prime x1, so it is equal to f prime 1, so you substitute x equal to 1, so you have a1 plus 2a2 plus 3a3, so you have a1 plus 2a2 plus 3a3. So now you see you have the a0, a1, a2, a3 are the unknowns, so I can rewrite this function. Okay, now what do you know? Okay, we have f0, which is equal to a0, which is also, what is your f0? So this is the one. We also have f0. Okay, so it's equal to f0. Okay, next, our f1, which is equal to a0 plus a1 plus a2 plus a3. So this is also equal to f1. So what is your f1? So this is your f1. Okay, so this is the value of fx1, which is equal to f1. Okay, so you have f1. So then this is equal to f1. Next, we have f prime 0 is equal to a1, and it is also equal to f prime 0 is equal to this value. Okay, so then we copy here, so we have f0 1, and then we have f prime 1 equal to a1 plus 2a2 plus 3a3, so you copy from here, which is also equal to your f prime 1 is equal to this value, so then you copy down here. Okay, so now we can rewrite this as I have a0 equal to f0, and then I have a0 plus a1 plus a2 plus a3 equal to f1, and then I have my a1 equal to f01, and then I have my a1 plus 2a2 plus 3a3 equal to f11. Okay, so what you can see, so I can write this in a system, I can write this system of linear equation in terms of, I can write this in terms of ax equal to b. So I'm not sure whether you still remember your linear algebra. Okay, please take a look if you forget. Okay, I can write in this form. So you can write your matrix A. Okay, so and then your matrix A will be, for the A0, for the first equation, you have 1. And then from the second equation, you have 1. From the third equation, you have 0. And then from this equation, you also have 0. And then you do the same thing for A1. So A1 here is 0. And then here is 1. This is 1. This is 1. And then for A2, this is 0. This is 1. This is 0. This is 2. Okay, you have 2 here. And then you have A3, we have 0, we have 1, we have 0, we have 3. Okay, so now this is your A. What is your X? Your X is A0, A1, A2, A3. So what is your B? So your B is F0, this F0, and then we have F1, and then we have F01, and then this is your F11. Okay, so you see you have a system of linear equations. So this is your matrix A, this is your Bx, this is your B. Okay, so now what you should do is you have to use elementary row operation to solve this. Okay, so I will show you only one operation, and the rest I would like you to try by yourself. I assume that you should learn this in a linear algebra class. So now you can write down the augmented matrix. Okay, so first of all, we write down the augmented matrix of this system of linear equation. So the augmented matrix will be 1, 1, 0, 0, 0, 1, 1, 1, 0, 1, 0, 2, 0, 1, 0, 3, and then followed by F0, F1, F01, and then F11. Okay, then for the first row operation is you want, this is your pivot, and you want, in order for this one to be your pivot, you need to change this one into 0. Okay, so I know that row 2 is going to change, and the operation will be row 2 minus row 1. Okay, then no changes on the first row, just write it down. Okay, for the second row, you have row 2 minus row 1, 1 minus 1 give you 0, and then 1 minus 0 give you 1, and then 1 minus 0 give you 1, 1 minus 0 give you 1. Okay, and then after the F1 minus F0, so you have F1 minus F0. All right, so I hope that this is clear. And then no changes on the second and the third, the third and the fourth row. So then you just copy down. So 0, 1, 0, 0, F0, 1. And then we have 0, 1, 2, 3. This is your F1, 1. Okay, you copy. Then you are done for the first operation. So the next one, this is your pivot, and then you want to change this one and this one into 0. So then you continue. So I will give you the next one. Okay, I say that this is my first operation. Okay, this is my first operation. So my first operation will be R2 equal to R2 minus R1. And then you have the second operation that will be, you can have arbitrary answer, not necessarily similar, but this is what I have done. Okay, as long as the final answer must be the same. Okay, your final answer should be the same. Okay, you can do 2 at the same time. Okay, and R4 is equal to R4 minus R2, and then the fourth one is your R4 equal to R4 minus 2 R3. Okay, so you by complete this, then what do you get? Okay, you will get your final form after the fourth operation is in this form: 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1, 0, 0, 0, 1, 1. Okay, and here you have F0. This is a F01, and then you have F1 minus F0 minus F01, and the last one is F11 plus F01 plus 2 times F0 minus F1. So you get the final in this form. Okay, so then you begin to solve. So then we begin from the last row. So from the fourth row, what do you have? Okay, so always remember, you know that this is your A0, A1, A2, A3. Okay, so we have A3 equal to F11 plus F01, and then plus 2F0 minus F1. Okay, and from the third row, we have A2 plus A3, which is equal to F1 minus F0 minus F01, and then you substitute your A3. Can you see that? You substitute this one into here. Okay, and then after that, from your second row, you have A2, which is equal to F01. Sorry, this is A1. Okay, this is A1 equal to F0 because this is A1. All right, and from your first row, you have your A0 equal to F0. All right, so I give you the final answer, and I would like you guys to check it out. by yourself. Okay, so finally we have, okay, your A0, A1, A2, A3 is equal to F0, F1, F01, and then you have 3F1 minus 3F0 minus 2F01 minus F11, and then the last one is F11 plus F00, F01, this is 1, okay? This is 1 plus 2F0 minus 2F1. Okay, so this is your final answer. Then, what is your answer? What is your fx then? Okay, so this is the final answer. So your fx is equal to, okay, now we know that your fx is, the formula is, if you see from the previous page, okay, let me find where's my previous page. Okay, here. Give me a second. Oops, I'm sorry, I just throw it away, but if you can see on the previous page, we have fx is equal to a0 plus a1x plus a2x squared plus a3x cubed. So this is the fx that we have. So from here, you substitute what is your a0. So you substitute your a0 is equal to f0. So this is equal to f0, and then your a1 is f01x, okay? And then this is your a2, then you put it by yourself. It's too long, I just lazy to write. And plus, this is your a3, okay? So this is your a3, and then x cubed. So then you are done. Okay, so you just plug into this function f. Alright? Then we are done for this example.